Hi everyone, and welcome back to the channel. I recently came across a mind-blowing statistic. Students born in September are about 30% more likely to gain admissions to elite British universities like Oxford and Cambridge than those born in the summer. At first, I couldn't believe it. How can something as arbitrary as your birth month have such an impact on your educational opportunities? Naturally, my curiosity got the better of me. I had to ask, is this just a fluke, or is there something deeper at work? And today I'm going to walk you through the statistical analysis behind this claim and explore the structural factors that might be causing this effect. The key question we are tackling is the following: does the birth month distribution of admitted students differ significantly from what we would expect if birth month had no effect? To answer this, we use a statistical approach called a goodness of fit test. Before diving into the data, we need a baseline assumption, or what we call the null hypothesis. A lot of people might just think that admissions should be uniformly distributed across all months, but that's not quite right. Births themselves aren't evenly spread out over the year. Instead, our null hypothesis is that the distribution of birth months among admitted students matches the distribution in the general population. If 8.5% of the general population is born in January, then, assuming no birth month effect, we would expect roughly 8.5% of admitted students to be January born as well. Let's take a look at the numbers from 5,300 successful Oxford and Cambridge applicants. September, 470 students. October, 515. November, 470. December, 456. And so on and so forth. In July, 384. And in August, 394 students. At first glance, there is a clear pattern. October has the highest count and February the lowest. But are these differences statistically significant? Or could they just be due to random chance? To answer that, we apply a powerful statistical tool called the Generalized Likelihood Ratio test. Essentially, we are comparing two hypotheses. Null hypothesis, which says admissions follow the general population's birth month distribution. Alternative hypothesis says birth month has an effect on admissions leading to a different distribution. This test quantifies how much more likely our observed data is under one hypothesis versus the other. For those who love the math, here's a quick rundown. We treat the data as coming from a multinomial distribution, since each student is born in one of 12 months. The test statistics is calculated by this formula, where Ni is the observed count for month I, N is the total number of students, which is 5,300, and Pi tilde is the expected proportion for month I based on population birth rates. For our data, this calculation gives a test statistic of 44.86. Under the null hypothesis, this statistic follows a chi-squared distribution with 11 degrees of freedom, since 12 months minus 1 equals 11. Comparing our results to this distribution yields a p-value of roughly 3 times 10 to the power minus 9. That's about 3 in a billion. What does this minuscule p-value mean? It means that if birth month had no effect on admissions, the odds of seeing the differences we observe would be astronomically low. Therefore, we reject the null hypothesis. The data strongly suggest that birth month does influence admissions outcomes. So what's going on? One likely explanation is the so-called relative age effect or Christmas effect. In the UK, the academic year starts in September, which means September-born children are the oldest in their class, while those born in August are the youngest. This age gap can lead to differences in cognitive and social development early on, advantages that accumulate over time, eventually influencing opportunities like university admissions. This analysis is not just about numbers, it shows how subtle, seemingly random factors can shape our lives in significant ways. Statistical tools like the likelihood ratio test help us peel back the layers and uncover hidden biases. Today, we saw how a rigorous statistical approach can reveal that something as arbitrary as birth month can affect who gets into elite universities. I hope you enjoyed this interesting statistical problem. What do you think about these findings? Are there any other surprising factors you would like me to explore in future videos? Drop your thoughts in the comments below, and if you have enjoyed this analysis, please hit the like and subscribe for more insights. Thanks for watching, and I will see you in the next video.